Hi everyone, and welcome to this Join Intel in AWS session. My name is Lubna Wortley, and I am the AWS EMEA Alliance Lead at Intel. I'm absolutely thrilled to be here with you today to talk about how Intel and AWS are working together to optimize your enterprise workloads. I have the pleasure to be co-presenting with Arti Raju, who is a Principal Solution Architect at AWS. Amazon EC2 offers the broadest and deepest instance choices for running diverse workloads ranging from HPC at extreme scale to mission-critical applications like SAP, Windows workloads, and hybrid applications. After a brief introduction, I will take you through the advantages of running your SAP estate on Intel-based EC2 instances. And Arti will go through the different benefits and options you have at hand to run your Windows, hybrid, and HPC workload. Let's start. As you know, every day, millions of customers trust EC2 to support their most critical workload. These customers range from the solo developer launching a new startup to big financial institution requiring high security. AWS has customers across every single vertical. In healthcare, we can find companies like Philips, AstraZeneca, and Thermo Fisher Scientific. These companies use AWS services to drastically reduce the time it takes to deliver new cures and to process massive amounts of genomic data. In the autonomous vehicle industry, customers like Drive.ai, Lyft, and Uber use AWS platform for machine learning algorithm. As you can see, customer use cases are broad, and Intel and AWS are working together to help them grow. But it's not just about breaking through on scale and performance. AWS continue to accelerate the pace of innovation. And just in the last few years, the number of instances has nearly quadrupled with over 300 instances today. This rapid innovation for you means greater choice of compute, networking, and storage offering, so you can better tailor resources in the cloud to optimize both performance and cost of your workloads. One of the reasons why AWS has scored so well in recent years is thanks to their amazing availability, as you can see on this map. In 2018, the next largest cloud provider had almost 7x more downtime hours than AWS. And we all know how critical that is when running your business application. Let's take a closer look at how Intel and AWS work together to drive innovation. AWS and Intel share a passion for delivering constant innovation, and our engineering team have been working together for over 13 years. The fruits of this labor include custom silicon and optimized software to deliver faster and more robust performance for the most popular enterprise workload. Together, we are continuously delivering new high-performance offerings for HPC, big data, and artificial intelligence. In the area of AI, Intel and Amazon collaborated to make reinforcement learning accessible to a broader community of developers through the cool AWS Deep Racer. AWS Deep Racer is a fun and accessible reinforcement learning platform used to make self-driving car a reality. And it is optimized on Intel technology. AWS Deep Racer is but one of many examples you can see here of how Intel and AWS are working together to deliver tools and services to accelerate your time to market and your learning curve. Amazon and Intel are obsessed in bringing value to our customers, to you. We focus on what matters the most by delivering the best price performance, scalability, and availability in the market. And we do this by listening, learning, and delivering. Let's take an example. In the HyperF Leanpack benchmark, EC2 Intel instances achieved up to 4.1x higher price performance. And this translates into real savings for you. For several decades, Intel has worked with leading software developers, operating system, and tool vendors, and has participated in thousands of open source projects. Intel has over 20,000 software engineers that work with more than 1,000 ISV ecosystem partners to optimize, test, and validate applications. Our goal is to ensure that any optimization we do at any part of the software stack, be it at the application level, for runtime or libraries, for container images, or at the operating system level can seamlessly migrate between on-prem, the edge, and the cloud. So each new version of VMware, Microsoft SQL, Oracle, SAP are all optimized and validated to work on Intel past, present, and future architecture. As an example, with SAP Workload, we achieved up to 480,000 SAPs using an EC2 high memory instance powered by Intel. This means you can concentrate on running your business, knowing that Intel and AWS have delivered industry-leading certified performance to meet your needs. Now let's take a look at how Intel and AWS technologies enable you to run enterprise workloads like SAP, Hybrid, Windows, and HPC in the cloud. Let's dive into SAP first. Since 2005, Intel and SAP have partnered to deliver better performance for SAP applications running on Intel architecture. In fact, Intel provided the original reference architecture for SAP HANA. Intel began early definition of the Intel Xeon E7 processor family at the same time as SAP started SAP HANA platform definition. As a consequence, the two have evolved together, resulting in one of the most efficient analytics platforms available today. All of the goodness from this close collaboration has been transferred onto AWS. SAP and AWS have been innovating on the cloud for over a decade now, since SAP first became an AWS customer. In 2016, AWS launched X1 instances. These were the only HANA offering for 2 terabytes scale-up and 14 terabytes scale-out at the time. And customers really liked them. 2 years later, in 2018, AWS had over 1,000 customers running the SAP workload on AWS. And the most demanding customers pushed AWS to go even bigger. So AWS launched the EC2 high memory instance for 6, 9, 12, 18, and 24 terabyte. These are the only offerings that run on bare metal and are integrated into a software-defined cloud infrastructure. Last year, AWS launched the only 100 terabyte B4HANA, followed by the only 48 terabyte S4HANA offering. Both continue to be the only native cloud-enabled options available today. As a result, more than 5,000 customers run the SAP workload on AWS today. Let's now take a closer look at one of AWS' latest innovation that SAP greatly benefit from, the Nitro platform. So what's the biggest challenge that SAP HANA represents? Well, AWS has certified more HANA instance type than any other provider, and they're all powered by Intel. This customer obsession and dedication enable AWS to determine that there are limitations to the in-memory performance of HANA when you try to virtualize it at higher volumes. So what was the AWS solution? A few years back, AWS acquired a company called Annapurna Labs. They are expert at optimizing compute and memory. With the acquisition of this skill, AWS developed Nitro. Nitro is a lightweight silicon-based device handling system that replaces traditional hypervisors and moves the management of storage, networking, and other forms of management from the RAM directly onto the silicon chip. This frees more memory for HANA, resulting in substantially better performance. In parallel to this truly unique platform that Nitro is, AWS has developed the most SAP instances for scale-up and scale-out powered by Intel. AWS and Intel engineers work together to design custom hardware based on Intel's latest technology to address performance and features SAP customers require. Let's take a few examples. As customers deal with larger data volume both on-premise and in the cloud, in-memory databases like HANA use compression mechanisms to scan data at blazing speed. Vectorization instructions such as AVX, AVX2, and AVX512 from Intel help exactly do that. Another example, as we scale with multi-user concrete usages in the cloud, executing transactions efficiently is a key requirement. SAP HANA uses Intel Transaction Synchronization Extensions, Intel TXX, to improve log scalability by up to 6x, as called out by Hasso Plattner, who is the co-founder of SAP, in one of his blogs. With those innovations, AWS Intel-based instances are certified to support the largest SAP S/4HANA scale-out environment with 48 terabyte, as you can see on the right-hand side of this slide, and BW for HANA scale-out environment with 100 terabyte. You can, however, start with smaller instances and easily transition to larger sizes when your data outgrows the instance. In March 2019, AWS announced another breakthrough for scale-up options with high memory instance. Those are the world's first 100% software-defined scale-out architecture for HANA. Those solutions are also AWS native offerings, meaning that they have the same cloud attributes customers have come to expect from AWS, such as elasticity, agility, and automation. These automation ultimately result in amazing provisioning and cutover speed. You can start your first HANA scale-out solution in a matter of hours, and you can cut over between memory sizes in a matter of minutes. All of the traditional infrastructure barriers have been removed, allowing you to innovate faster than ever with SAP. Let's now take a look at the different instance family from left to right. The first one up are the R5 instances. R5 instances allow you to set up smaller scale, entry-level deployment for SAP HANA. R5 instances provide twice as much memory per core, 8:1 versus 4:1 versus a general purpose M instance. They offer up to 25 gig of bandwidth and up to 3.6 terabyte of local NVMe SSD. So you and your customer can get faster results for your in-memory intensive applications. The next one up are the X1 and X1E instances. On the left-hand side, you can see the X1 instances. They have up to 2 terabyte of memory and the lowest price per gig of RAM. X1 instances are ideal for running in-memory databases like SAP HANA, big data processing engines like Apache Spark or Presto, and high-performance computing applications. X1E instances have up to 4 terabyte of memory, and they offer the highest memory per vCPU among AWS instances. They are great for running in-memory intensive workload like HANA or database workload with vCPU-based licensing. Last but not least, the high memory instances. With scalability of up to 8 sockets, you can process more within the same server rather than having to go over the network to connect to additional sockets. This architecture reduces latency for in-memory databases. They have the highest amount of memory of any EC2 with up to 24 terabyte of memory. EC2 high memory instances are available in Amazon Virtual Private Cloud and are connected to AWS resources out of the box without requiring any hybrid architecture. These instances support elastic storage capacity on high-performance Amazon Elastic Block Store volumes. You can launch and control your instances from AWS command line interface, and they are already integrated with AWS Identity and Access Management. Those instances are available as bare metal instances on EC2 dedicated host. This means those instances can also take great advantage of AWS Nitro system, providing unparalleled performance, security, and efficiency of the infrastructure. By now, you should have a clear understanding of the benefits and the different options you have at hand to run your SAP workloads on EC2 instances powered by Intel. Arti will now take you through the next enterprise workload, Windows, and SQL workloads. Arti, over to you.
Thanks, Leo, for sharing how Intel is optimizing SAP workloads. Hi, everyone. My name is Arti Raju, and I'm a Principal Solutions Architect with AWS. During the rest of the presentation, I will walk you through 3 other key workloads: Windows, hybrid and low latency applications, and high-performance computing. What we are going to be talking is how Intel-powered instances are being used to optimize these workloads, features that you can benefit from, and performance aspects. As Lou mentioned in the first segment, AWS has been built to support virtually every workload with its broadest and deepest compute platform that is available. If we focus on Windows workload, AWS has over 11 years of experience running Windows applications, and over 50% of all Windows deployments in the cloud run on AWS. Let's take a closer look at how some of the key things for Windows, with licensing, performance, and programs that are available for you can benefit you. When it comes to Windows, the first question I typically get from my customers is, hey, how does licensing work? AWS offers flexible cost optimization choices, and customers can choose options from one of the three that you see here. Flexible pay-as-you-go licensing choices, bringing your license mobility benefits to AWS, and bringing licenses to AWS without paying for software assurance. The flexibility that we talked about with licensing is achieved with dedicated hosts. If you aren't familiar with what dedicated hosts are, this is an Amazon EC2 dedicated host. It's basically a physical server with EC2 instance capacity fully dedicated for your use. These allow you to use your existing per socket, per core, or per VM software licenses, including Windows Server, Microsoft SQL Server, etc. This is critical for customers with existing investments in Microsoft licensing agreements that they have, which might have dedicated tenancy needs. You can seamlessly launch virtual machines or EC2 instances on these dedicated hosts, just like how you would launch an EC2 instance with AWS-provided Windows license. You can also then integrate this with License Manager, which I'll talk about, and define your licensing terms and management preferences for these dedicated hosts. I mentioned License Manager. So this service helps you to keep track of your licenses on AWS. So with License Manager, you can centrally track licenses counted by either the vCPUs, cores, sockets, or instances across all AWS accounts and hybrid environments. We recently introduced automated discovery of bring your own license usage of products such as Windows Server, SQL Server, and Oracle as a new feature in License Manager. The best part about License Manager is that it's available to you at no additional cost. Moving on to performance. DBBest shared in 2 blogs on how to get the best price performance for running SQL Server in the cloud on AWS and also the next largest cloud provider. CK Research took these blogs and compared the results to share an apples-to-apples comparison on performance. Based on this comparison, compared to other cloud providers, SQL Server on AWS consistently shows a 2x better price performance using HammerDB. The first chart shows cost per 1 billion transactions per month. You can see that AWS is cheaper. The second chart that you see here shows the performance of SQL Server. As you can see, SQL Server on AWS outperforms the next largest cloud provider. Especially for Microsoft SQL Server, Amazon EC2 M5 instances, which we recommend, has the latest Intel Xeon scalable processors and are ideal for specific use cases such as running Linux and Docker containers, in-database advanced analytics, etc. Before we move on to the next workload, I wanted to quickly introduce you to the Windows on AWS migration program. We call this the End Support Migration Program, and it's a program that helps you to migrate from legacy Windows Server applications to the latest without having to do any code changes. Now let's move on to our next workload, which is hybrid and low latency applications. As we continue to work with our customers on their most mission-critical applications, we've heard from customers a couple of things. That there are some applications that will remain on-premises, and these are customers who are betting on the cloud, but have scenarios which need sub-millisecond latency. An example would be something like delivering real-time and medical diagnostics and imaging to physicians, or operating manufacturing process control systems and automated plant assembly lines, which all requires millisecond latency. AWS offers this consistent experience across cloud and on-premises via a couple of services that we're going to talk about: Outposts, Local Zones, Wavelength, and VMware Cloud on AWS. Let's take a look at these services. With Outposts, many of the objections that prevented customers from adopting hybrid solutions, like different control planes, different APIs, software patching, etc., have been removed. All the things that customers can use to control their AWS environment, they can use the same control plane with Outposts. Outposts extends AWS on premises by delivering AWS infrastructure, native AWS services, APIs, and tools to virtually any connected customer site. You can choose from a wide range of EC2 instance types and EBS storage options that are best suited for your applications. Intel-powered EC2 and Outpost instances provide the consistent infrastructure that you would get when you're running an EC2 instance in the AWS region. The key is that it provides that single pane of management between your workloads running on premises on an AWS Outpost and within an AWS region. The catalog that we have today for AWS Outposts includes options supporting the latest generation Intel-powered EC2 instances, and these could be categorized into general purpose with the M5s, compute optimized, memory optimized, graphic optimized, etc. Now let's take a look at how VMware Cloud on AWS is enabling these hybrid use cases. When we launched VMware Cloud on AWS, our goal was to help customers running VMware workloads on premises to migrate to the cloud and have a consistent experience without having to re-architect their application. A couple of use cases that we see customers using VMware Cloud on AWS for are data center lease expiration, data center extension, disaster recovery, large cloud migrations, and application modernization. With VMware Cloud on AWS, customers can launch a VMware Cloud environment within less than 2 hours in the cloud, migrate their workloads without refactoring their applications. From a performance standpoint, we recently launched the support for a newer instance type called i3en.metal for VMware Cloud on AWS customers. Customers have been asking us for instance types that have more storage and with this i3en, this is based out of Intel's Cascade Lake processor, and it comes with approximately 60 terabytes of raw storage. So vSAN uses the storage from the NVMe devices to provide high performance for workloads such as NoSQL databases, data warehousing, etc. Finally, we have AWS Local Zones and AWS Wavelength. Over the last year, as we've talked to a number of customers using Outpost and VMware Cloud on AWS, we have identified new scenarios where customers need similar low latency use cases with single-digit millisecond latency requirements. But these customers do not have an on-premises footprint or do not want to invest in a global infrastructure. We launched AWS Local Zones to cater to these requirements. What Local Zone does is it extends the AWS infrastructure deployment from an existing AWS region, bringing AWS services closer to the edge. Another important use case is with the emergence of the 5G technology. We're also looking ahead of the next set of edge use cases. We believe 5G has the potential to create a new class of applications, and we're partnering with telcos delivering compute at the edge to enable these 5G use cases. With Wavelength, customers can use the same AWS infrastructure, services, and the APIs that they're familiar with, and also the same deployment tools for their low latency mobile application use cases as they do for their other applications in the cloud. Moving on from hybrid and edge use cases, let's take a look at our final use case, which is going to be high-performance computing. From weather modeling to genome mapping to the search for extraterrestrial intelligence, the high-performance computing space, HPC, has always been about solving the world's most complex problems. The AWS HPC solution combines the latest compute, networking, and storage and cloud orchestration that you just saw to offer a highly customizable computing platform. By moving your HPC workloads to AWS, what you get is the instant access to the infrastructure capacity you need in order to run your HPC application. The AWS HPC solution that we offer allows you to choose from a wide variety of compute instance types that can be configured to suit your needs, which means you can select the CPUs, GPUs, or FPGA-powered instances. EFA, which is our Elastic Fabric Adapter, a network interface for Amazon EC2, has a unique OS bypass networking mechanism that provides that low latency, low jitter channel for that inter-instance communication required for HPC workloads. Instances such as the C5N, the EFA, and the 100 gigabits of networking come together in order to enable you to run your HPC workloads in the cloud securely with ease and performance and also low cost. HPC workloads, as you know, demand fast processing and high-speed networking with a lot of fast memory and storage. We do offer a wide range of instance types that you see here, and you can see specific use cases for these instance types. I'm going to drill down on the Z1D instances in particular. These instances offer high compute capacity and also a high memory footprint. High-frequency Z1D instances deliver a sustained all-core frequency of up to 4 gigahertz, the fastest that you will get of any cloud instance. Z1D provides both high compute performance and high memory, which is ideal for electronic design automation, gaming, computational lithography, etc. I mentioned before that capabilities such as the EFA and the 100 gigs of networking come together to enable your HPC workloads in the cloud securely. The EFA enables customers to run these applications requiring high levels of intercode communication at scale on AWS. With EFA, HPC applications using the message passing interface and ML applications using the NVIDIA Collective Communications Library can scale to thousands of CPUs or GPUs. As a result, you get the application performance of an on-premises HPC cluster with the on-demand elasticity and flexibility of the AWS cloud. Before we conclude the HPC section, I wanted to quickly share a few charts on how C5N instance type and EFA are enabling computational field dynamics and also computer-aided engineering codes to scale on AWS. The charts that you see here indicate how well some of the commercial CFD codes scale when using C5N instances with the EFA networking. In both the star CCM and the Fluent charts that you can see that the C5N EFA plot tracking quite closely to the ideal scenario. To summarize today, Lubna and I walked you through 4 key workloads for your enterprise applications. We've dived into SAP, Windows, hybrid and low latency applications, and HPC applications. Hopefully this presentation has driven home the message that how Intel and AWS, along with our other partners such as SAP, Microsoft, VMware, and many more, are committed to making your cloud migration experience a positive one. On this chart here, you'll see all the Intel-based EC2 instances and some of the key features of these instance types. If you have any questions about these workloads or want to dive deeper, please contact your solutions architect, AWS Solutions Architect, to get a deeper discovery into what these workloads are and how they can benefit you. Once again, thank you for your time today, and please let us know how we can improve this session. Thank you and have a great day.